All right, let's dive into something that might just completely flip how you think about reality itself. We're going to explore a wild idea called information geometry. It suggests that the universe isn't just empty space with stuff in it, but a landscape with a very specific shape, the shape of meaning.
So, let me just start by asking you a really basic question. We all learned that space is this big, empty void, right? A container for all the galaxies, stars, and us. But what if that's just not right? What if space isn't empty at all?
And let's push that even further. What if space actually has a texture, like a fabric? Not a physical one you can touch, but an informational one. A surface that we can actually explore and measure, one that holds the hidden structure of the entire cosmos.
Okay, so first up, we're going to have to completely rethink the fabric of reality. We're going to look at what this so-called texture is actually made of. And trust me, it's not what you're probably thinking.
This idea gives it a name, a statistical manifold. Now just think of it as the landscape that everything in the universe exists on. But here's the kicker. This surface isn't made of atoms or energy. It's literally woven from pure information. And this is where things get really wild. Think about the concept of distance. We measure it in meters, miles, whatever. But in information geometry, distance is measured in something called distinguishability. The real question becomes, how different is one point in space, one state of reality, from another? That's the true measure of distance here.
Okay, so if the universe is this textured, information-based surface, right, there have to be some rules to the game. Rules that dictate its shape and how we move around on it. So let's check out the core principles that this whole idea is built on.
So there are three core axioms holding this all together. First up, the sentience first principle. This basically says that geometry itself is a map of experience, how different one state feels from another. Next, we've got the finite quota. This suggests there's a limited budget of total experience in the universe, and space is just the most efficient way to organize it all, like a cosmic compression file. And finally, there's the 10 to the 24 law, which says gravity isn't a fundamental force at all. Nope, it's something that just shows up, an emergent property, when you zoom way, way out and look at the big picture.
So, how in the world do you measure distance on a landscape made of information? You can't exactly use a ruler. We need a totally new kind of tool, one that measures things in units of, get this, surprise.
And that tool is called the Hessian metric. Now, don't get bogged down in the math. The idea behind it is actually beautiful and simple. The Hessian is our measuring stick, but it doesn't measure length, it measures how fast the meaning or the experience of a particular state is changing. It's all about the rate of change.
This makes it so clear. Think of it like this. A place with high curvature is like a steep hill. Things change fast. It's intense. You feel a kind of force. But a place with small curvature, that's like a flat, boring plane. You get stasis, predictability, a lot like the vacuum of deep space, just flat and unchanging.
All right, now for the big payoff. This is where it all clicks into place. Let's see how this brand new framework gives us a completely different way of looking at a force we feel every single second of our lives: gravity.
We've all heard this, right? It's the famous line from Einstein's general relativity. The classic view is that big things, like planets and stars, literally bend the fabric of spacetime, and we feel that bend as gravity. Simple enough.
Well, this new perspective flips that completely on its head. It says that objects, or what it calls high coherence patterns, basically stable, information-rich things, don't bend physical space, they pinch the geometry of information. So what we feel as gravity is just the natural tendency for things to roll downhill toward these areas of higher meaning, higher coherence. It's the path of least resistance through the landscape of meaning.
And you can see here this whole theory builds up logically, step by step. It's not just some random idea. It all starts with a basic premise. There's a finite amount of total experience. That experience then gets broken up into all the possible states. You add some variety and connections between those states. Then an optimization rule kicks in, making the system efficient. Our measuring stick, the Hessian metric, pops up to measure the local change between states. And finally, when you zoom all the way out, the global curvature that we call gravity just emerges. It's the natural result of all those local interactions.
So, what does this all mean? What are the huge, sweeping implications of this? Well, if space is really information and gravity is the pull toward meaning, it changes how we see, well, pretty much everything.
For example, think about the Big Bang. In this model, it wasn't some physical explosion happening in space. It was the moment the metric itself unfolded.
It was the moment the universe went from a single uniform point to a vast landscape of different possibilities. The universe didn't get bigger, it got more detailed. It became distinguishable.
And this is what brings this huge cosmic theory right back down to you, right now. Every single time you move your hand, you're not just pushing it through an empty void. You are actively navigating the slopes and curves of this informational landscape. You're following the natural pathways of potential and meaning that are woven into the very fabric of reality itself.
I just want to leave you with this one last really powerful thought. Space is not a container, it is the resolution of our shared experience. It really makes you wonder, if the universe isn't a place we live in, but a shared story being told at an incredibly high resolution, what does that make us?